Let us deep dive into the lexical scoping in lambda expressions. So, what is it actually? Lexical scoping means a lambda expression can access variables from the scope in which it is defined. That means its surrounding context. So, scope is determined by where the code is written, not where it is executed. Let us see the code and let us see the core idea behind this. A lambda can access local variables if effectively final. If those variables are effectively final, it can access local variables. Also, it can access instance variables or fields. Also, it can access static variables. So, it cannot modify local variables. Let us see some example here. We have variable declared with name int marks of type int and it is initialized with value 40. So we have predicate of type student with variable name is passed, and on the right hand side we have lambda. So as followed by the lambda operator s dot get marks greater than or equal to pass marks. This one. So here pass marks is captured from outer scope. So it is captured from outer scope. Lambda uses it without redefining. So lambda makes use of this local variable without redefining it. Let us see the mental model. Lambda is a function with memory of its surrounding scope. If we think of lambda as a function with memory of its surrounding scope. So here we have to remember the rule, which is effectively final rule. So let us consider this scenario where we declare a variable and initialize a variable like variable name int pass marks of type int, and we are initializing with an int literal 40. So after that we are modifying it with 50, with the value as 50, pass marks is equal to 50. After declaring and initializing we are modifying it with some other value. Now if we make use of this variable, it doesn't work. So what is the correct way? Like this. Once initialized, we shouldn't modify it to use that local variable. So definition: a variable is effectively final if its value is not changed after initialization. So a variable is effectively final like this if its value is not changed after initialization. So here it is not changed right after initialization, so it is effectively final. why this restriction exists. Now let us see why this restriction exists. Java enforces this because lambdas may run in different threads because it prevents inconsistent state. Inconsistent state. So the state should be consistent. So for preventing inconsistent state, this restriction exists and ensures predictable behavior. The value is not changed. What does it mean? It ensures we have the predictable behavior. Now let us see instances as local variables. We have a class defined with name, class service, school service, and inside this we have instance variable with name, pass marks of type int, and it is initialized with value 40, int literal 40. So we have method name check. Inside this method we have predicate of student followed by the lambda expression. So what we are doing here, we are making using of this instance variable. Now after making use of this instance variable, we can now modify it. Pass marks is equal to 50. So this is allowed. In the case of instance variables. Now let us see the case of local variables. So we have method check. Inside this we are declaring and initializing a local variable with int literal 40 of type int. Now after making use of this local variable, if we try to modify this value, it's going to be a error. So it cannot be modified in the case of local variables. So this keyword behavior. Now let us see this keyword behavior. In Lambda, let us see this example. We have a class called school. Inside this class, we have a method void test. Inside this method, we have inner class. Variable r is equal to we are actually defining a lambda here. Variable r is equal to open and close parenthesis followed by the lambda, and where we have a statement here inside this system.out.println this. Here this refers to enclosing class instance. Here this refers to this enclosing class instance. So in the anonymous class, something like this, runnable R is equal to new runnable R. This refers to anonymous class instance. But whereas here, this refers to enclosing class instance. What is enclosing class here? School. The school's instance, this is referred. So what is the key insight here? Lambda doesn't create a new scope for this. It doesn't create a new scope. So let's see variable shadowing rule. So it is not allowed in Lambda. So in marks we have variable declared initialized with variable name marks of type int with an int literal 50. So we have a predicate here. So after s dot get marks, we are assigning it to the same variable marks with some return statements. So here we are getting error. Why? Because lambda shares the same scope. It shares the same scope. No variable shadowing allowed. Shadowing happens here. So no variable shadowing allowed. But is allowed in anonymous classes. Like this. These are some real world usage scenarios in our school system. So dynamic rule creation. So here this variable is declared initializer like this, and we are assigning this to lambda. So config driven logic. For config driven logic like this. Int fee limit config dot get fee element, and then we are making use of this variable inside the lambda expression. So service layer uses. So how it internally works, how Java handles it. Let us see how does it work. When lambda captures a variable, value is copied. When lambda captures a variable, that value is copied, not referenced like closures in some languages. So its value is copied, stored internally. So just like we discussed, it must remain unchanged. It must remain unchanged. It should be effectively final. So three things it happens. Its value is copied, it stores internally, it is stored internally, and it must be remaining unchanged. That's why effective final is required. So these are some Common pitfalls. Trying to modify captured variable. So it is captured variable, right? Here we have inside the lambda, we're trying to modify this count plus plus. So we're getting error. So confusing scope with anonymous class. Lambda is not equal to anonymous class. Lambda is not the same as anonymous class. So overusing external variables. In j is equal to b, into b is equal to 20, in c is equal to 30. So overusing these external variables is a bad thing to do. So in the memory we have pass marks. This is a local variable. It's stored in the stack, and lambda reference also is stored in the stack. But when it comes to the student objects, those are stored in the heap. Also lambda instance is also stored in the heap memory. So let us see another mental model here. Lambda access to outer variables. Lambda can access to outer variables, but it cannot change them. It cannot change them, that we have discussed. Let us see some final takeaways. Lexical scoping, access to surrounding variables. Lexical scoping is nothing but accessing to surrounding variables. Local variables must be effectively final. They must be effectively final. Once lambda captures the local variable, they should be effectively final. This refers to enclosing class. This refers to enclosing class in which the lambda is written. So no variable shadowing. No variable shadowing. Once the variable is declared initialized, if the lambda captures that, and inside the lambda it shouldn't shadow the variable. So it enables clean functional code, dynamic rule creation, and conflict driven logic. Let us see this lexical scoping in demo. For now, let me create a package with name lexical scoping. Let me create a class lexical scoping demo. So what I will have inside this class, I will have a main method definition. Let's create a variable name pass mark of type int and also initialize this variable with the int letter 40. Now let us have the predicate of student. Let's create a student first. With some variable, instance variable, private int pass marks. Predicate of student. Let's import this. Is passed. Variable name is read passed is equal to student dot get marks. So we'll have constructor and also we'll have getter as well. Student dot get marks. Sorry, actually I should be creating with marks only. So constructor and also with the getter. Student dot get marks is greater than equal to pass marks. Is passed test new student. Let us assume that this student has got some 50 marks. So result. So what is the result here? It should be passing, right? If student's marks is greater than equal to pass marks, what is the pass marks here? 40. So here lambda is capturing the surrounding variable. So let us try to debug this. Debug fate result is true. Here result is true. Fine. Now let us see the other scenario. Let us release this breakpoint. Now let us see the other scenario where let me try to comment this code. Int pass marks is equal to 40. Again, what I am trying to do here, I am trying to modify this pass marks as 50. So up to this it is working. Now I will do the same thing. So It is showing error, right? Variable used in lambda expression. So variable used in lambda expression should be final or effectively final. So it doesn't work. I'm commenting it out. So it should work. Why? Because variable used in lambda expression. Here, this variable used in lambda expression, it is effectively final here because we are not modifying it after it is being initialized. Now, let us see the scenario of instance variables. Let us see the scenario of instance variable. We have seen the scenario of lexical scoping as far as local variable goes. Now let us see the scenario of instance variables. For that, let me create a class called school service. Inside the school service, I will have instance field declared and initialized. Int pass mark is equal to 40. Inside this class, I will have a method called check with predicate student. Let me import this class. It is available in java.util.function.predicate. So predicate is equal to student dot get marks greater than equal to pass marks. So let us try to modify this now. Instance variable is equal to 50. So if you try to observe this, it is not flagging in this case because it is an instance variable, so it is not flagging here. But when we try to local variable after using inside the lambda expression, there we got error, right? So here we are not getting an error. So what is the bottom line here? Instance variables can be modified after using inside the lambda expression. But in the case of local variables, not modified. Modification is not possible. Now let us see this keyword behavior. For that, let me create a class called school and let me create a method void test inside this class, and we have a lambda runnable or is equal to some system statement this. Here this refers to this enclosing class instance, that means school class instance. But for anonymous class like this, new runnable, this refers to this anonymous class instance. Now let us see the case of variable shadowing, whether it is allowed in Lambda or not. For that, let me create a class called variable shadowing lexical scoping demo. Let me create a main method. So int marks is equal to 50. Let us have the lambda student p is equal to, let us import this predicate, student int marks is equal to s dot student dot get marks. So some return statement, return marks greater than 40. So here it is flagging us, saying variable marks is already defined in the scope. So variable marks is already defined in the scope. So we are trying to shadow it. It is already defined in the surrounding scope. So we are trying to shadow it. So it is not possible. But it is allowed in anonymous inner class. Let us see that in demo. Variable shadowing anonymous cross demo. Let us have main method inside this. So int marks is equal to 10. Now let us see the case of runnable R is equal to new runnable. So creating in a class here. So again into marks is equal to 10. So it is not flagging anything because variable shadowing is allowed inside the inner classes, but not in the lambda. Now let us see the scenario of our school context that we have been developing. So, Lexical scoping demo to main method. So, int attendance threshold is equal to 75. So, we'll do one thing here. We'll create a sub package. Lexical scoping 1. Inside the sub package, we are just moving this into this, and we will do one more thing. We will create a class student inside this. So int attendance. So attended days. Attended. Okay, let us make it simple. Attendance. Let us have constructor. Let us have getter. Let us make it a private because it is a poser. Fine. So inside this, what we're going to do, we have predicate of student eligible. What the eligible criteria? The attendance should be greater than attendance threshold in your school system. So attendance threshold is how much? 75. The student attendance should be greater than or equal to attendance threshold. Now eligible dot test. New student. Let us assume that the student has got 90. Attendance 90. Result. Let us keep a breakpoint here. Let us try to debug this. Await. So result true. Passed. Right? Now this time what we're going to do, means we will make it as 60. Now let us see the result. Should this time what should we get? We should get fail, false. Now let us see one final demo. Yeah, it is already over. We will just wrap this up. Thank you very much.